Okay, let's hook up Lab 5. Lab 5 we're going to be doing metering out, just like we do in pneumatics, but you know, we can actually meter in hydraulics as well. And the difference between when we would meter in and when we would meter out in hydraulic is all about looking at ascending or descending loads. So if I have a load that's descending, so I'm actually putting pressure in to force it to go down, what I want to do is I want to meter out for sure. If I want to slow down that load going out, there's that flow going out, I want to slow the flow going out so that I can control the speed going down. For ascending loads, that is when we meter in. So if I've got a load that I'm lifting up, whether I'm pulling it up or pushing it up, however you want to look at it, when it's ascending, I'm pushing something up, I'm going to meter in. So we're metering out right now, so let's just hook up this circuit. I'm going to start building my circuit with the basic connections, and then I'm going to go and kind of hook it up as it flows. So let's hook up my basic connections over here. We're going to go from pressure over to pressure here, and put my tank connection on. Always doing the simple ones first, and then I can kind of start to hook up the rest. That's more of the logical control of what's happening here. Also, I want to check the pressure here, so I'm going to hook this meter up so I can always see my system pressure. Now I can start my circuit. So I'm going to run my circuit. I'm going to hook up my circuit the way the flow is going to go. So I'm just going to kind of start from my DCV. I'm going to go into my cylinder and start hooking it out as the flow goes out. So right now, nice and simple, I'm going to hook up a line coming out of my DCV to extend my cylinder. Here we go. Now I have a couple options here when I'm coming out of here. One is I can go into my metering valve and put a T there, but I also need a gauge here. So we actually have already a connection that's already got a gauge on it. So I can just stick this on my cylinder. Now I got a line coming out of here, and I can go into my metering valve. Okay, so into my metering valve, I want to make sure that I hook up my metering valve the right way. So I'm always going to say, well, I'm going to hook it up on the ball side or the other side, but here I'm going to hook up on the ball side. So when you're doing metering, you're actually always hooking it up. When you're doing metering out, you're always hooking it up on the ball side. There we go. Sometimes they don't fit always easily, but sometimes they do. Okay, now what's going to happen is I'm going to run a line out of here into here so that I can study the flow of the liquid coming out of the cylinder, and then I'm going to go into here. But I also need to put a check valve in here. So when I'm doing that, it's going to be in parallel with this. So I'm just going to do this. I know that I have to connect in parallel, so I'm just going to put two check valves in here. Sorry, two T valves in here, and then from there I'm going to run one to my check valve, but these guys also are going to come from this flow out of here. So let's do that. So I'm going to take the flow coming out of my metering valve, and I'm going to go into my flow valve, or my flow meter, out of my flow meter down to my DCV. Now I won't forget about my check valve. Okay, so I've got that guy hooked up. Now, these guys have to connect to the check valve. Again, I have to make sure that I get the polarity right. So I'm looking at the line coming out of here, which is actually the top of this, because the flow's going through this. The line coming out of here is going to be on the ball side, okay? The line coming out of here, which is the in to the meter. On the diagram, it's the top of the meter, and here it's the lower part. I'm going to go into a check valve on the ball side. Cool. Now I'm going to come out of there and go back in parallel to my meter. The reason we do this is so that when the fluid is flowing the other way, because sometimes the fluid has to flow out of here and into the cylinder this way. When it's doing that, We don't want to make it go through this the other way. We want to give it a free path to go through here. As opposed to going through here, it's going to go through here, through the check valve, and then out. Okay, so we're hooked up. Let's run it. So, we know our procedures. You're going to make sure this is wide open, all the way down. That is this way. I'm going to turn this guy on. Now, before I did that, I checked to see that was in the middle. Now, what I'm going to do is I'm going to slowly turn this on and watch for pressure. There's no pressure. Okay, so now I can pick this up. I'm going to watch this and put this up to 500. There we go, I'm at 500. Now, what I'm going to do is, I'm going to release my metering valve. I'm just going to open it up all the way. And I'm just going to see how things flow. And now, I'm going to look at the lab and try and follow the procedures. I'm just going to test to see if it's running properly right now. It's going out. It's coming in. Okay, good. So now what I want to do is I want to take some readings. So I'm going to flip this thing over. And we'll look at what we're studying. What I want to do is I want to study the flow rate going through this meter while this is extending, depending on what this is set to. So if I meter it more or less, I want to study if the flow rate changes. So let's do that. This procedure tells me to set this thing to 250. Okay, so I'm going to put it down to 250. So now that I got it at 250, what I'm going to do is I'm going to put this up, I'm going to throttle this a little bit, and I'm going to let this run to see what happens. And what I want to do is I want to set it so my flow rate is a specific amount. And that is going to be one, okay. A specific amount, which is 1 gallon per minute. Okay, good. So let's run this and see what happens. See if I can get this to 1 gallon per minute. Okay, I'm at 2. I'm just going to turn it around. I know that I have to meter it more so it slows down, which means my flow rate is going to be less. Okay, let's try that. Oh, I'm getting a little closer. So I have to throttle it a little bit more. And we just do this until we get it. Okay, so I'm at 2.5. I'm going to do that. Return it. Sorry, it was a 1.5. I'm going to turn it maybe a little bit more. You'll get a feel for how this works. There we go. So I'm just above 1, and you can see it's moving more slowly. So I'm going to turn that to there. Test it one more time. I think I got it. Yep, there you go. It's a little over 1, but I'm going to stick with that. Maybe I'll kick it down just a little bit more so I can get it right on 1. Okay, I'll say that's right on 1. Okay, good. So now I got 1. Okay, good. So you've got that reading. You know that when it's throttled to this amount, you control the flow rate, and the flow rate is 1 gallon per minute at 250 psi. Let's kick the pressure up a little bit. So your lab says you should kick it up to 350. Okay, so let's turn this up to 350. Now we'll run it and see what the flow rate is. Oh, look at that. It's a little higher. It's 1.5. Okay. So make a note of that. Now I'm going to kick it up to 500 and I'll watch the flow rate. Wow, it's almost 2. So we can see that depending on the pressure, we can see that the flow rate is going to change. Now I want to do that again. But let's watch the pressure on the rod side, and we'll see what happens there. So I'm going to retract this guy. It's fully retracted. Let's extend it. I've got 500 psi here, and we're going to watch the pressure there. Wow, look at that. So is that more or less or exactly 500? So if you do this one more time, take a look at it. It'll go all the way up to 700 psi. What's up with that? I mean, my system pressure is 500. Why is that 7? So that's a good question for you to think about. Let's just do maybe one example where I'll kick the pressure down. Maybe I can, if I turn the pressure down, it will be the same. I don't know, but let's experiment. Okay, good. So I'm going to take this down to 200. We'll put it down to 250 because that's the number we had before. Now, this is at 250. What's that going to be? So watch this meter. So I know I'm at 250, but I mean 350 there. So that's kind of interesting. What does that mean? Well, it's a good question for you to answer. To further this study, maybe I can push it a little bit more and kind of tweak things and see what happens. I know that my pressure there is higher than the system pressure. What I'm going to do is, I'll put it at 500. What I'm going to do is I'm going to kind of really throttle it a lot. So I'm going to slow the flow down that's coming out of here a lot. And we'll see if that affects it. Wow, it's up quite a bit. So it seems as though when I throttle the fluid coming out of the cylinder, it actually creates more back pressure. Now there are other reasons why there's a higher pressure here. Let's actually get rid of the throttling completely and see what the pressure is. See if it's the same as 500. Oh, it's really, really low. Okay, so throttling seems to change what's going on the other side of the cylinder as far as pressure goes.